The objective for this video is to calculate the mean for a grouped frequency distribution. In a previous video, we used the data for the number of electoral votes for each of the United States to construct a grouped frequency distribution. Without access to the raw data values, it is impossible to calculate the exact value of the mean for a data set. However, it is possible to approximate the mean for a data set that has been summarized in a grouped frequency distribution. The procedure for finding the mean for grouped data assumes that the mean of all of the raw data values in each class is equal to the midpoint of the class. The class midpoints are used as reliable approximations since some values fall above the midpoint and others fall below. Step 1 will be to make a table with the following headings: class, frequency, which we will abbreviate with the letter F, midpoint, which we will abbreviate as X with a lowercase m in the subscript, and a final column that will contain the products of the corresponding class frequencies and midpoints. Step 2 will be to find the midpoints of each class. The class midpoints can be found by adding the class limits and dividing by 2. This can also be thought of as the average of the class limits. So for the first class, we would add 3 and 10 and divide by 2. So the midpoint for the first class will be 6.5. Continuing this process, we find the rest of the midpoints to be 14.5, 22.5, 30.5, 38.5, 46.5, and 54.5. Step 3 is to multiply the frequency by the midpoint for each class. We will call this the products of the frequencies and the midpoints. In the first class, we will multiply 34 by 6.5, which will give us a product of 221. Continuing this process, we find the rest of the products to be 159.5, 45, 61, 38.5, 0, and 54.5. In step 4, we will find the sum of the values in the last column. This will be called the sum of the products of the frequencies and the midpoints. The formula looks like this. The sigma symbol means to sum or add up, and then we have the products of the frequencies and the midpoints. Adding each of these products, we find the sum to be 579.5. In step 5, we will divide the sum of the products of the frequencies and the midpoints by the sum of the frequencies, which is the size of the dataset N. The formula looks like this: X bar, and we use the symbol for sample mean since this will be an approximation of the mean for the dataset that was used to construct the grouped frequency distribution. Again, we have the sigma symbol, which means to sum the products of the frequencies and the midpoints, and then divide by the size of the dataset. The size of the dataset will be the sum of the frequencies. This sum will give us 51. So, to carry out the evaluation of the formula, we will divide 579.5 by 51. The rounding rule for the mean tells us to round to one more decimal place than occurs in the raw data. So using this grouped frequency distribution, we estimate the mean number of electoral college members per state to be 11.4. The actual mean number of members per state is 10.5. Our estimate of the mean using the grouped data was 11.4 members per state. The discrepancy occurs because in the absence of the raw data, the individual data values for each class were estimated using the midpoints of each class. In this video, we learned how to calculate the mean for a grouped frequency distribution.